So this problem we're given, well, okay, an aircraft factory makes airplane engines. The unit cost is C. That's the cost in dollars to make each airplane engine. Depends on the number of engines made. That is, as they make different number of engines, the costs are going to change. So if X engines are made, the unit cost is given by this formula right here. C of x equals 0.1x squared minus 32x plus 8803. What is the minimum unit cost? Well, this is a quadratic function, and we know that maxes and mins of quadratics occur at the vertex. So we could graph this we can graph this equation to find out what the minimum unit cost is, and that's what I did. I graphed it on Desmos on my computer, and below I have a video that I'm going to play, and I apologize, the audio is going to be a little bit spotty. You should still be able to hear it, but it's going to come in and out. But let's watch this video and see how we can graph something like this online and then find what the minimum cost is.
So in order to graph this, we're going to use Desmos. It's an online graphing calculator system. So just go to desmos.com, and then you'll click something that says Start Graphing to pull it up. So I'm just going to type in my function that we saw. It's written down above. C of x equals 0.1x squared minus 32x plus 8803. Now, I don't see my graph at all. That's because such big numbers are involved here. So what you can do on Desmos is if you click on the screen, you can drag the graph around. And if you hold down the shift button around one of the coordinate axes, the y-axis or the x-axis, you can actually change the scale this way. So I'm just going to keep dragging this down until I get a glimpse of my graph, and look, there it is. And now I'm going to change the scale of my x-axis. I'm going to bring it into focus, and there's my graph. Now on Desmos, if you click the graph close to some important points, it'll make them show up. For example, if I click over here close to this y-intercept, then it plots that point. And I can see that the y-intercept is at 0.8803. Don't care about that. In this case, I'm trying to find the minimum, which is at the vertex of this upward opening parabola. So we get the information right there. So that tells us that the minimum unit cost is going to be 6,243 when they're making 160 of the units.
So yeah, so there's the solution. When x is equal to 160, then y is equal to 6,243, and that is that point right there, that minimum point, which tells us that the minimum cost is $6,243. And you can always use the graph like this to find maximum and mins when it's a quadratic function. You just graph it, find where the vertex is, and there's your answer.